Hello everyone, and today in this video we are gonna teach about or I gonna discuss about binary search. In the previous video we have already seen about linear search here, and this is I told you this is a technique of searching an element inside an array. We are in array chapter and we have already discussed how to search an element using linear search. So this time we are going to learn about binary search. Okay, this is binary search. This is another technique of searching a particular element. For example, the element is n, whether this element entered by the user is present in this array or not. So the same example I have taken of length 6, an array of length 6. Now the problem with linear search is, what's the problem with linear search? Linear search, what happened was we were checking each cell or each rooms, you can call these all cells. This is a cell, this one, and all these are cells. So each cell we were checking that whether the value present here is that n or not, and like that all the rooms were checked by us. Now for example, just imagine if there are 100 or sorry 1000 of rooms, then exactly each room we have to check whether that element is present in that room or not. Is it possible? Yes, it is possible, but I think it will require more time, or it becomes little hectic. Okay, from 1000 rooms means from 0, that is 0, 0 to 999. All the rooms we have to check. Now you can say that what if we find the element in 5th position and still we are gonna check, we have to check because the loop will continue till 999. Okay, even if we get the element. So to make it simple, we can easily if we get the element at 5th position, we can easily write a break statement and get out of the loop. Then we don't have to run the loop for 1000 times. That is, yes, that makes the code more convenient, but it can be much more convenient if we use binary search. Now what is binary search? There is a disadvantage in binary search also. Let us start with that disadvantage. Let's start with that disadvantage. The disadvantage is that since, not that since, this is SINC, since, okay, since we will not be searching, or we will not be checking each box one by one like linear search. Okay, we will not be searching each box one by one. We will check it in a different manner. Okay, we will not check like that each box, we will not check. Since we will not check it by each box, so the disadvantage is we have to arrange the whole array. The array should be sorted. For binary search, to take place or to work with binary search, the array should be sorted. The array should be sorted either in ascending order, or in descending order. In whatever order you want, you can sort the array first, or rather take input a sorted array and then apply binary search on it. I think I'm clear up to this. So after sorting the array, then only we can apply our binary search. So for sorting also there are a few techniques: selection sort, bubble sort. I will discuss it in later videos. First, let us focus just on binary search. What is the concept of binary search? Now everything has its meaning from the word itself. Let us see the word binary. Binary means two. Binary means two. Bi means two. Binary means two parts, you can say. So what our approach will be, what we will do is, or basic thing, just to understand, just for you to understand, what will be our basic approach. What will be our basic approach is that our basic approach will be to divide this array into two parts. How? Okay. First, we will find the mid position, the midpoint, the midpoint. Okay, midpoint of the array. Midpoint of the array. midpoint of the array we will find. Now obviously it cannot be a point because it will be integer we have to take. So it will take a integer which will be a midpoint of the array. How midpoint? Because this is the 0th position, this is the 5th position. We will add the two numbers and divide it by 2. That means 0 in this array. In case of this array, we will add the lower or the lowest index and the highest index and divide it with 2. 5 divided by 2 is 2.5. But since it is a integer, we will take just the integer, so it will take 2. So 2 is our midpoint. That means 0, 1, 2. This cell will be our midpoint. So first I am just let's not go into the numbers. We are just trying to understand what will be our approach, what to do. First let us understand. We will first find out the midpoint of the array. Then we will check the number we have to search. The number we have to search in the array, whether this n is present in this array or not. We will check whether this n, the element, because I told you the array is sorted. So we will see the element present at the mid position of the array is greater than n or less than n. Either it is greater than n or less than n. Okay, if n is greater than the element in the mid position, that means n is on this side, on the right side of the mid position of the midpoint, or the axis or the midpoint, you can say n is here. Or if the n is smaller than the mid position, then n is somewhere here. Okay, somewhere here before the axis or the mid position. And if it is greater than the mid or element in the mid position, means here element will be there. For example, 5 is there. Okay, so what we will do is, this is the midpoint, whatever. This is the mid position. Okay, or the middle of the room, and the array is sorted. All the things are in ascending order or in descending order. So we will check. We will for our convenience, we will arrange it in ascending order for our own convenience. But you can arrange it in descending order also. Just the conditions will be different. Just the opposite will be. Doesn't matter. Okay. So first we will check whether the element present at the mid position of the array is greater than the value n. We have to search. N is the variable. We have to search whether n is present in this array or not. So we have to check whether n is greater than the element present at the mid position or not. If n is greater, then obviously n is present somewhere on the right, or n is present somewhere on the left. So these are the two divisions. Okay, these are the two divisions. 5 will be somewhere here. Okay, then we have, I think, two columns will be here. Wait, we will not actually divide the array. I told you wrong. We will not actually divide the array, but we will think like that we have divided the array. Okay, 5 is in the middle, and then we have 3 more rooms here. Okay, we will check whether, means after this condition satisfies, we will get to know whether n is on this side or n is here, where n is present, where. Okay, and on which side n is present. If we get that n is present somewhere here, then this will be our what to call it, upper limit or upper bound, or our highest or maximum point. This will be, and this will be our lowest or mean position, LB, or lower bound, you can call it. We call it lower bound. Okay, this cell will be our first position or 0th position, and this will be our last position. Again we will find a midpoint of this array. If n is present here, again we will find a midpoint of this array. Okay, and then we will check whether n is on the right side or n is on the left side. Okay, after doing this all things, after following this step, until and unless this lower bound remains less than equals to upper bound. Until this happens, what will happen is that mid position, MT, I am denoting it with mid position, our mid position will be equal to that value of n. This condition will be reached if n is present in that array. If n is present in that array, we will get to see that the midpoint once in a while will be equal to the element itself. Let's summarize it all. We have an array. Simply we will understand. We have an array. Let us divide it into few pieces. Let's just not focus into the numbers. Just let understand what to do. We have an array, sorted array in ascending order. This is the lower bound or the lowest position or the 0th cell. Okay, this is the upper bound or the highest position or the last cell. Okay, we will find the mid position of the array. We will check then mid position. Let us denote it with P. We will find the mid position P of the array. Then we will check whether the value to be searched n is on the right side of P or on the left side of P. Okay, these are the two divisions. Now, if the n is present on the left side of P, then obviously the right side of P is of no use. Right? Obviously it is of no use because n is on the left side of P or the mid position. Then the right side is of no use. No use of searching the element on the right side, obviously. And if the opposite thing happens, if n is not present on the left side, n is present on the right side, then no use of checking it further in the left side. Obviously, no use of checking it further on the left side. Sorry, excuse me. No use of checking it further on the left side. So this reduces our task of checking extra elements. We will just divide the array into 2. Okay, and like that we will divide it and finally get this P will be equal to, or rather the element at the mid position will be equal to n. Once in a while it will happen if n is present somewhere in the array. Okay, if n is present somewhere in the array. Okay, now if I told you if in is present on the right of P, then the lower bound will become what? You have to change the lower bound because we don't need this part, means we don't need this left side part. We need something after P. After P, all the elements, those we need. We don't need the elements before the mid position. So L, just apply logic. LB or lower bound will be what? Lower bound will be P plus 1. P plus 1 it will be. 1 more than P. Means after the mid position, from that part, the whole array. Upper one will be remain as usual if n is present on the right side of mid position, and if it is on the left side of the mid position, then lower bound will remain as it is. Upper bound will be P minus 1, because before P to the 0th element, all the elements we need, because n is somewhere there, or else n is somewhere here. This thing will be more clear if we write it in code format. Let's go. So linear search we have already done. We will just change few things here and make it binary search. Binary search. Let us keep it. Sorry. Binary search. 6 is the length of the array we have kept. Okay, we don't need this. What we need actually is, we need a lower bound, I told you, will be 0. We need a upper bound which will be 5, because 6 is the length of the array. So 0 to 5 the index numbers will be. This I have already discussed. Another variable we need, that is k, which will become 1 if we get the element, and we will then break. So k the value of k will tell us that whether we got the element or not. Okay, now enter elements of array. We got the elements of array in sorted format. So in ascending order, I am writing it here in ascending order. Otherwise, you have to arrange it in ascending order. But for the sake of convenience, in this video, I am assuming that all the elements entered will be in sorted order. Okay. Now, enter the element to be searched. Let's keep it as n because we have discussed it with n. So let us keep it n. The element we got. Now here the part is little bit difficult. Not difficult actually. Let's write. We will write it with while loop. While LB less than equals to UB, because you can see LB is getting smaller and UB is decreasing, LB is increasing. So a point of time will come when something will increase or decrease, or this condition will dissatisfy, obviously, because those two values are not constant. Okay. Sorry, they will either increase or decrease. Yeah. Now we will have to find out the mid position. Now let's declare a variable p which will hold our mid position. P is equals to, write it one up here, P is equals to LB plus UB, the upper limit and the lower limit, divide by 2. The mid position we got. Now we will check if the array was m comma p, this is the mid element at mid position. Sorry, element at the mid position of the array. Whether this is less than n, so this is less than n, mid position is less than n, mid position is less than n, or rather we can write yes, mid position is less than n. That means n is greater than mid position. That means n is on the right side of the mid position. N is on the right side. That means this is the case. This is the case this time. N is here. N is, sorry, this is in the ascending order and the mid position is greater. So n is here. Sorry, my mistake. I don't know. This is little confusing. Just to understand it. Wait. Let me clear it. Yes. If this is the p position, the middle position, then I told that the middle position is, I wrote middle position is less than n. Sorry, less than n. I wrote, yes, less than n. Less than n. So n must be here. Yes, I was correct about it. N must be here. N is somewhere on the right side of the mid position. Sorry. Actually, my health, I have little health issues, that's why. Don't mind. Okay. So n is somewhere this side. So that means UB will remain as it is. The upper bound or the maximum index, you can call it highest index, that will remain as it is. Just lower bound will change. How it will change? LB be equals to P plus 1. LB will increase. If M P, that means mid position, is greater than n, that means n is on the left side of the middle position, that means UB will decrease, P minus 1. That will happen. Like this will happen. Okay. But like after happening these things, one time will come when M P will be equal to n. If n is present there, then this stage will come. Otherwise, this stage will not come. Now, how we will know that this stage has arrived inside the program? For that, we have used that the variable k. Now, whenever it will enter here, that means this condition is satisfied. So k will become 1, and it will break. Done. Now we will check whether the value of k is equal 1 or not. If it is, If it is, then element found, else element not found. Let's check this. Let's check it. Achha. We have to enter it in ascending order. So let's enter 4, 6, 8, 9, 10, 1, 2, 3, 4, 5, 6, one more, 15. Now enter the element to be searched. Let's give it 10. Element found. See, it was in ascending order, that's why it gave element found. Okay, so like this it works. You can take a screenshot if you like. If you want, you can take a screenshot, or you can just pause the video and write this source code if you want. Okay, so what we have done is actually we have taken array. The name of the array is M with size 6. Now we need a lower bound and a upper bound. Lower bound means the lowest index, 0th index obviously starts with 0, and upper bound is the last index. In this case, the last index is 5. Done. We have declared a k variable just to know whether the variable or the element is present inside the array or not. That we will get to know in the further program that we have used it here. Okay. Now n stores the value to be searched, and p stores the mid position of the array. Now we have taken all the elements of the array inside the array. We have taken it as input, and then we have entered the element to be searched inside this n. Now the main part is we have written a condition, a while loop we have run, that is while LB or the lower bound is less than equals to upper bound. While this will occur, every time a mid position will be found. Okay, mid position will be lower bound plus upper bound divided by 2. Okay, now we have to check. I can write a comment here also. Now we have to check. Let's write a comment. We have to check whether MP, that means the mid position of the array, is less than the number to be searched, n. That means n is present. That means what? N is greater than the mid position. That means n is on the right side of the mid position. That means after the mid position, after the mid position on the right side, all the elements we need. On the left side elements we don't need. That means what? N is on the right side of the mid position. This means that. That means lower bound will always obviously increase, because lower bound was 0, but from 0 we don't need now. We need from lower bound becomes 1 more than the mid position. That means after the mid position to and the last element, up to the last we need. So in this case, upper bound will not increase. Okay, for this case, upper bound will remain as it is. Lower bound will increase, and we will have to change that pointer somewhere else. Where? After the mid position. But if MP, that means the mid position, the element at mid position is greater than n. That means n is on the left side of the mid position. N is somewhere on the left side of the mid position. In that case, the lower bound will obviously start with 0, because n is on the left position, but upper bound will not be, or the last index will not be the 5, because now we don't need the right side elements. We just need the elements just before the mid position. So obviously we have to change the upper bound. So upper bound upper bound becomes 1 less than mid position. 1 less than mid position. Done. After doing all these, after that, if the element is actually present inside the array, n is actually present, then this condition will occur. This time, because how much small it will make the array. Once in a while, you will reach a stage, where you will have only one cell. Okay, and that should contain your element. Okay, that should obviously contain your element. Okay, if the element is actually there if the element is actually there, after breaking it into parts, lower bound, upper bound, then mid position, again lower bound, upper bound, mid position. So once in a while you will get to reach a single cell, and a single cell obviously it will have only one element, and one element, if the element to be searched is present in that array, then obviously that is the element in this cell, present in this cell, the element is present in this cell only. So that is the situation reaching here. This is here where the situation is reached, where we got the mid position as our element. The mid position of the array is at that mid position, the element is present. That element only we need to find. That element is our element to be searched. If that condition satisfies, then k will become 1. K previously we have initialized 0. Here k becomes 1. If k becomes 1, it will break. It will come here outside this while loop. Here it will arrive, and here it will check whether k equal 1. K equal 1 means this condition was satisfied. If this condition is satisfied, that means we got the element. So here I have declared or written in the terminal window that element is found, or element found, else element not found. So I hope you got to know about binary search. Binary search only works if the array is arranged in ascending order or descending order. Remember that. Please remember that. Okay. So if you got any value from this video, or if you got to learn anything about this video, if I was able to share something with you, then please subscribe the channel and write in the comment section how you got to know, or what you got to know, how you felt listening to the video, and did you get any value or not, or if you want me to increase the quality or do something else so that you will feel interested, then please let me know. I want to learn from you also. This is just a learning channel that where you will learn, I will learn, we will grow together. Thanks for watching today's video, and thanks for giving me this time. Thank you very much, and let's meet in another video. Okay, till then, bye bye, take care.